Welcome to the Masters of Engineering podcast, episode 29. A fantastic guest today. He's not only the head of the mechanical engineering department at MIT, but he also is an additive manufacturing 3D printing entrepreneur of note with several companies, most notably VulcanForms. He's making some of the most amazing metal 3D printed parts in the world. He's doing some of the most amazing research and teaching. Professor Jon Hart of MIT, welcome to the podcast.
Thank you, John. Great to be here.
Great to have you here. It's a great one because in my podcast, in my work building CAD and PDM software, I get to meet all these cool product developers, and the goal of the podcast is for my audience to get to meet them too. And I think they're going to really love hearing from you. You're not only a professor and head of the department at MIT, but you've been involved in founding several businesses and a researcher as well, right? So you're research, teaching, education. How do you balance all that and think about doing all these different things?
The first answer is I don't. I always struggle, and I'm pretty busy. But honestly, it's one thing that makes MIT special, that we have opportunities to continue our research and teaching and take leadership roles while continuing to further our interests in entrepreneurship. And what I've learned from being involved in starting companies outside of MIT has fed back into my day job, whether it be in the classroom or working with grad students in the lab, or now in this relatively new role as department head.
That's well, and it is a real honor, I'm sure, to be named department head, and indicative you must be doing a good job if you've got the company going. You're not just a professor, but department led. Let me ask you, VulcanForms, and this amazing article was in the Boston Globe newspaper not too long ago, right? Sometime within the past year, anyway. They called VulcanForms the most interesting startup in America. Pretty high thing. Can you tell us what is VulcanForms?
So VulcanForms is a manufacturing company. We think it's a new kind of manufacturing company that uses digital technologies from the factory floor to the customer interface to consolidate supply chains and enable the future of advanced products. Now that's a bit kind of cushy description. The nuts and bolts are we make precision engineered metal components at scale using additive manufacturing, 3D printing as a cornerstone technology, but not just additive, a number of processes that fit together in an end to end process for orthopedic implants, components of aviation, defense systems, jet engines, et cetera, even some consumer products and other industries as well. And I co-founded the company with Martin Feldman, who was a student in our Masters of Engineering, our MEng program in manufacturing, who started in 2013, and VulcanForms is kind of our joint product, but really the credit goes to Martin for being the CEO from day one and being an amazing leader to continue to drive the company forward. It's still early; nothing's proven yet until you're really long-term stable as a manufacturing company. But John, as you saw, we have about 150,000 square feet in Devens, Mass, an hour west of Boston, and a really exciting facility where we're making parts for big customers, and that's what it comes down to is doing production at scale.
So there were a lot of other companies making metal 3D print. There were and are a lot of other companies. You had been involved in founding one of them, right? Desktop Metal. A lot of companies making metal 3D printing equipment, and a lot of companies I visited, our own customers, they're involved in manufacturing parts using those printers that they buy. So with all those companies making printers, all those essentially 3D printing service companies, many of our listeners would be familiar with some of these. Why start VulcanForms? What was the need that you saw?
Because we felt back in 2015 when we had the idea that 3D printing was failing to meet its potential at an industrial scale. And we saw that as a technology issue that the existing technologies for metal 3D printing, particularly we use an approach called laser powder bed fusion. We have our new approach to it, but it's an established process. We thought there was a technology gap. We also thought there was a business model gap, that to bring 3D printing to scale, it needed to be part of an end-to-end production system. So, lots of great companies, innovation in the additive industry, but VulcanForms' approach from early on has been not to sell printers into the marketplace, but to integrate our additive technology with other processes and sell finished parts to customers. And it lets us control the value chain. And for the way we are doing business, it fits with our customer profile. Customers in the end don't care as much as how a part was made. Maybe it's important that it's 3D printed because it has some unique geometry or lattice structure like an implant, but they care about getting finished parts at the right quality at the right time. And that's how we've carried our approach forward as a business.
Well, it's very wise because I always say to people, whether they're my customers who are building 3D printing equipment or customers, that the real business of 3D printing is not making the printers or materials, it's making parts. It's the quality of the parts that matter because that's what you need. And so you mentioned that you're using a laser process that is somewhat, well known and understood, the laser fusion, but you're doing it in a different, cool way. Can you talk about that, the scale and scope of how you use laser?
Yeah, so the company was founded on the technology idea and then ultimately the business approach. The technology idea being that, unlike current laser powder bed fusion printers, if you're a 3D printing nerd like me, you know what I'm talking about, that have one or a few lasers that are independently scanned, we figured out a way to combine a whole lot of laser power into one integrated system that allows us to have a single machine that can use about 100 kilowatts of laser power. So in
Wow.
terms of power draw, you have, say, 100-to-1 ratio. And in terms of what that means in terms of productivity and quality, there's also a very, very significant jump. And that becomes kind of the Lego brick of a factory where you use 3D printing as the primary forming process. But then after the 3D printers, you have heat treatment furnaces. And then for many parts that require CNC machining, you machine the parts too. And one example, this in my hand is not specifically a VulcanForms part, but we're working heavily in the medical industry. This is a section of a geometry that would be the acetabular cup of a hip implant, a well-known application of metal additive made out of titanium alloy and 3D printed because titanium is a real pain to work with, but also because you get this three-dimensional lattice structure on the surface. And I'm showing you this part, it's probably hard to see on the screen, also
Yeah.
because it's not just printed, but after it's printed, it's machined. You see the shiny surface on the inside. So you really need that end-to-end integration. And from the VulcanForms perspective, as I said, kind of owning the value chain lets us consolidate the experience for customers. It also lets us use our understanding of how to design the part to be formed additively to inform the downstream steps, right? The heat treatment sets the microstructure and the properties. The machining is necessary for the finished tolerances. If we know we have to machine the surfaces, we can design the part to facilitate that and also to minimize the extra amount of material that we have to remove in the end. And I feel that industry writ large, whether it's the technology providers or the big customers, are starting to see this integrated vision as the way forward, and we're really happy to be one of the leaders in that area.
And okay, a lot there. I'd love to ask a few questions. Now, the Globe article said, quote, 150 laser beams. That's in the newspaper. Can you
Yeah.
comment on that? Is that accurate?
Yeah, so we have machines with between 75 and 150 laser beams that are combined together to come into the machine. I can't say much more about what's kind of under the hood, but that's a core aspect of our RP and our technology is how we combine and control the lasers to print parts, whether it's an array of small parts like tiny spinal implants or even things like housings for smartwatches, or it's like one part at a time that's a big part. And I have a pretty big part here.
Ah, great. Now we're about
Not
to
that
see.
strong, but hopefully you can see it. It's
Oh yeah. Okay.
this is not a customer part, it's a marketing part. It's the kind of part that would be like a stator ring of a small jet engine. Our machines are 600
Unbelievable.
millimeters across, and this is made out of Inconel 718. Actually printed a couple years ago at the early stage of our factory build out. So I love having it in my office because it's from the first production printer in Devon's. We call them Devon's printer, really creative, right? DP1. So this part was printed on
DP1.
DP1.
Okay. And that part
And
held up just for the benefit of our audience. Some people are watching the video and they could see it. For those who couldn't see it because they're just listening, that
yeah,
part is about, did you say 600 millimeters? Gosh,
just under 600 millimeters in diameter. So the build plate in our printer is 600 by 600. So the biggest part we can make is 600 by 600 in plane. And actually we made it a cube, so 600 millimeters tall. And once the printing is done, the process is not done. You have to take the build plate out, let it finish cooling, take away all the excess powder we call depowdering. Then you do heat treatment for stress relief and also for microstructure evolution. And then you have to cut the part off the build plate. We typically do that with EDM, electro discharge machining. And the build plate is a reusable substrate. We can resurface it and then you send that back into the printer and then the part is free. So I held up the part, it's a ring. I don't have the build plate. That would be a 3-inch thick or so block of titanium that gets sent back and kind of reused in the process.
And so you're using, say, you said 75 to 100 plus, so about 100 times as many lasers as a laser printer, a laser metal printer that I might be familiar with. And you use all that energy. Is the goal there that you print in parallel for speed, or you use direct more power? Like what's
So more power equals higher speed, right? Because if you can melt more metal versus time, you can be more productive, but you have to use that power very carefully. So another key is our software that lets us program how we scan the lasers over each layer and the power that we use at each specific location, each pixel in a layer, or you could say voxel in 3D, to make sure we apply enough energy to melt the metal, melt the powder, fuse it together, but not overheat it. And that lets us get very consistent uniform properties. Another general aspect of our approach is instead of having conventional mirror scanners, right, it would be hard to imagine having 100 sets of galvo mirrors or thereabouts up in the roof of the machine, impossible to control. We have a gantry apparatus. So we scan the lasers effectively over the powder bed. And that allows us to get very, very good position control, and very good consistency of that laser exposure in each layer. And that's really key going to production, knowing that everywhere a part is being scanned, whether it's a region of a very large part, like the big ring I held up, or if it's many individual medical implants, get the same experience, are effectively under the same process conditions. And when you get into how you qualify the parts for customers and for certification agencies, that's also really, really important.
So to be clear, and can you confirm you're really set up not to receive parts one off from like if there's a listener out there thinking, oh, I'll print a part with them or whatever. You're not a service bureau for printing individual parts. You're really about creating a production process to make parts at scale. Is that right?
Exactly. And prototyping is really important, but we don't work with customers who only have prototyping needs. And when we start with a new customer, you always have to start somewhere. So you're typically
Yes.
printing test specimens and small quantities, but we want to build a relationship and really build an enterprise level relationship, to use a kind of software word, with our customers over time. So we understand organizationally how we work together, and then we can go and innovate together. Like, we want to be the production platform for the next generation products that our customers will sell into the market. And understanding our capabilities and being able to deliver for customers lets them design their next generation products for our production capabilities.
That's great. And can you mentioned a moment ago some different types of applications. To the extent you can talk about it, I imagine a lot of your work is confidential, but to the extent you can talk about it with us, Are there any parts in particular that you can tell us about from your customers that you're able to discuss publicly?
In general terms, and we can't name customer names, unfortunately, but we are working with quite a number of Fortune 100 companies in different industries. We have a big focus on the medical industry, particularly 3D printing of orthopedic implants, or you could say digital manufacturing of orthopedic implants. And the reason there is the geometric flexibility and the fine lattice structures you can make, as well as the massive supply chain consolidation when you think about managing the large number of sizes. We're not talking customization yet, but just the number of sizes of implants in different portfolios. So orthopedics is one. Another vertical is, we call it A&D, aerospace and defense, components for jet engines and other flight hardware and space hardware and so on. And a third area is consumer electronics and what we're calling tech. So, I didn't initially think this, but that we see huge opportunities in using our manufacturing process for components of the kinds of devices that we all have in our pockets or on our wrists, and components in like computing hardware. So it turns out one of our first production parts was with a customer. They approached us to print a small metal part that's used in the thermal management system for a very, very large chip that's used to train big AI models. And we were able to produce this little component with our process, and no other supplier, additive or non-additive, they had reached out who was able to do it. And it's because of the dimensional tolerances we could hit because we scan the lasers. So there's a nice example where these components are being used in these large computers. We're not doing the compute, but this component is a critical component to make the system work overall.
Very, very cool. And can I ask you again, I don't want anything that, just feel free to say if you can't say this, but are there any parts out there in use today? Could I meet someone who has an implant that you printed, or you don't have to say who it would be, or is there vehicles in flight or cars that are driving or AI being trained? And are any of those things happening with parts that you've made to the extent you could discuss it?
Yeah. So implants in people, not yet, but coming. It will be there. AI being trained, yes, and parts flying, yes.
Cool. So there's parts flying. I mean, I got to say that I hope you're really proud of that, because as you know, I spend my life talking to people who design and manufacture things, and we sell our software products, CAD and PDM, here at PTC, to people who design and manufacture. I think there's a huge it must be hugely satisfying for you as an engineer and an entrepreneur to actually know there are products out there. That's not just studies and prototyping, it's actually happening. Is that satisfying to you?
Yeah, it is. Thank you, and I appreciate it. So I think it's important to be able to stop and reflect. You get caught, like I'm sure you can imagine, and many of the listeners can imagine, you get caught in the day to day, and sometimes like, okay, let's step back and see what we've done. But it's still early. Like manufacturing is so hard to change, and it's hard to innovate together with big companies. And I think we're hopefully just scratching the surface of what we can do in the future. I think the most rewarding thing is to see that we've been able to form a new company and see the company grow, and many of the early employees still work there, and see their pride and their dedication to the evolution of the technology and the business, and also be able to bring on new talent, from young talent to really experienced executives who drop in and help us lead forward, because there's a lot of challenges still to be addressed, especially in how we grow the business and how we position the company to be to grow, to continue to grow.
Let me ask you, you are an expert on additive manufacturing. I love that you teach it, you research it, you're doing it yourself now. What advice, a lot of our listeners use or are planning to use additive 3D printing, do you have any top three things they should think about, or the chronic errors you see when people come to you? Do you have any quick advice on how people can improve how they think about and use additive generally?
Great question. First and foremost, I've learned it's about product innovation, understanding how additive can be a tool along with other tools to create new products, or to create new flexibility, versatility in your product life cycle, if not your product development process. And it makes me a little bit nostalgic because, funny enough, the way I got into additive and kind of the way VulcanForms started was because I decided in my first semester as a faculty member at MIT to teach a class on additive. I didn't know much about it, but something made me say, "Oh, I'm going to try to teach a class and get students together to like teach it with me." And Martin, who started VulcanForms with me, was in that class. And he really launched the company. We founded the company in 2015 and raised our first funding in 2017. So a bit of a digression, but thinking forward, and in the context of the student, whether a university student or a professional learner, it's about thinking of the product life cycle and how to create innovative products with these technologies. And some of the struggles, honestly, that the additive industry has had, kind of ups and downs, I think, are about, in part, sometimes the assumption that additive is an everything technology and you have these everything machines. Never been the case, but what are the value driven use cases that can pull the technology forward? And that can be prototyping, or it can be production, or it can be something entirely in between. And that has really become the backbone of how we teach additive, especially to industry groups.
With the idea of aiming at product innovation.
Exactly.
Yeah, I think that's a great point. And I also think you said that in between part, and this is just me, and I'm really here to hear you, but just to check, in my travels, and I visited almost 50 customers last year, 48 or so, one a week, except for the holidays. And I saw a lot of use of additive, and it seems to me a lot of it's being used, if not for end user products, for what I'll call internal use products that are more than just a fixture or a tool, but something that is made that's very important to a company, but may not get shipped to the customer. Would you
Definitely.
agree with that?
Yeah, definitely. That's a great point. And so we've had an online professional course for about 5 years that's had about 10,000 professionals enroll over time. Like, really proud of that.
Yeah.
And we've evolved that to now, along with the online course, to have a new set of in-person workshops. And we're typically aiming these toward cohorts of engineers and other roles at specific companies. And we bring them to campus for 2 or 3 days, and getting, say, 30 people in the room from the same company, from different functional parts of the company, and hearing their ideas is so rewarding and so exciting. And they might be talking about tooling, or might be talking about end stage production, or kind of internal use products, as you say, and that is really exciting and leads to ideas, and then context specific learning about certain technologies, and kind of cost modeling, business case evaluation. So that's the core of how we do it.
Wow. And then how do our listeners and viewers, how do they learn more? This about this MIT. This is a professional education class. So you don't have to enroll at MIT as a student. Again,
Correct.
some listeners are familiar, some aren't. How do we learn more about that?
So if you Google this MIT additive manufacturing course, I think Google will take you to the right place. You might see an online course and an in-person course, and we also do our kind of custom workshops. So likewise, feel free to reach out to me. You can use the email before, or you can use my MIT email, which is ajhart@mit.edu, and either of those reach me and works just fine.
Have to ask you, because my world is building CAD and PDM and other tools here at PTC. What do you need us to do? Not PTC as a company, but our industry, let's say, of CAD and PDM tools. What do you need us to do for to support you and your customers in the additive future?
Yeah, that's a wonderful question. I pause a bit because I haven't thought so much about it beyond the academic context. But some things that come to mind are, if one's pushing the envelope on complexity of geometry, things like lattice structures for implants, being able to represent that data compactly and do robust finite element simulation and so on, and then kind of slice 3D geometries into 2D layers and have high fidelity in the slicing. Those kinds of I'm rambling a little bit. Those kinds of pipeline
No,
tools are really
this
important.
is fantastic.
Uh,
Yeah.
Second, here at MIT and especially colleagues such as Fayez Ahmed are very excited about the power of AI on the front end. So kind of physically driven AI tools to search large design spaces or compute certain performance metrics. And I hope that the ecosystem of CAD tools evolves to interface with those possibilities and keep the human solidly in the loop. And then last, less well formed, but we talked a bit about the downstream, right? We get a lot of data from our process. We're just starting to think about, in the VulcanForms context, how we use that data for more rapid qualification. It's useful to do rapid process development. What does it mean for qualification and certification? And that connects to like model-based definition of CAD models and products from customers. And I think there's a lot of future there if you think about taking this process to the limit. Because in the end, right, it quote should be completely digital, completely seamless. Like send in a part, you know, it can be determined quickly. Can that part be made? What's the cost, et cetera, et cetera. We're not there yet, but stitching the tool chain together will certainly accelerate that and make that more possible.
Oh, that is a great list, and um, couple of comments here at PTC. We are working pretty hard on MVD. It's out in our Creo product and in the Onshape product. It's coming. We're really excited about it. We spent a lot of time thinking about how it could be done better than ever. And AI, you mentioned quickly. I'm just going to add for our listeners. You mentioned the name Fayez, and I want to elaborate for our listeners. That's Professor Fayez Ahmed, Ahmed, right? Who's in your department, the department you had, Jon, at MIT, Fayez. And I'll just put in a good word. I have gotten to know Professor Fayez Ahmed in his work in his Decode lab, part of your department, DECODE at MIT, in AI and the future of product design. I think Fayez Ahmed and his students, in my opinion, are doing amazing work. And I'll thank you as department head because you're kind of one of his bosses, if you will, right? And so I'm really impressed with the work they're doing in that group. And anyone who's interested in AI and the future of product design, I think the research that's going on in that group is fantastic. So thank
Thanks.
you.
Yeah, I so highly recommend checking out his work if you're interested, and it's a great pleasure to be his colleague and to be working together on some projects. In fact, we just released a perspective paper on next gen AI tools for design and manufacturing, led by Fayez and his team.
That brings you another, in your role as an educator, can you tell us about the state of education of mechanical engineers generally, not just about AI or additive, but just generally, because you run that department at one of the world's leading departments in mechanical engineering. What's on your mind as an educator? What do people need to know about the education of mechanical engineers and how it's changing now and into the future?
To me, the future of education in mechanical engineering is combining the age old principles with the emerging areas, right? Like, how do you teach the principles of solid mechanics and fluid mechanics and heat transfer and so on, while exposing students and empowering them with the latest computational capabilities to be able to augment how they learn and do more complex calculations. Along with that, we need to continue to emphasize the hands-on aspects and learning by doing and stopping and thinking. And understandably, our brains are being rewired by uh, the frequency with which we look at screens and how a lot of kids grow up these days. And it's really important to us in Mechie, I'm sure among other places, that we continue to emphasize the hands-on aspects of our curriculum and the ability to design and engineer, a machine, a robot, you name it, from first principles yourselves, and then become comfortable using the engineering tools that sort of give you the superpowers to do more, to do faster, to reach higher performance. And so I think pedagogical innovation in our department is called guided discovery. It's brought forward by Professor Ellie Sachs, who he's been working on this for many years. He's actually the first MIT professor in 3D printing back in the day. You must know Ellie. And I think you've seen this, John.
Grad
Uh,
student, he was
yeah,
talking about 3D printing, and that was a long time ago. I'll tell you, this is like 40 years ago, right? Ellie Sachs was.
started
Hey,
in the late 80s, I believe.
I'm very
Yeah,
excited
but
to
so
hear about Ellie.
but
Yeah.
Ellie's passion is this approach to teaching, where in our undergraduate courses, not all of them, but some of them, such as introductory solid mechanics, before students would be taught a particular principle before the lecture, they sit down in a lab and they interact with a physical setup that allows them to do quick experiments where they are asked questions and answer questions to predict like the physical behavior of materials. So take this kind of rubbery beam and twist it and tell me how the cross section is going to deform, or a setup with a kind of flow input and a floating ball and measure pressure versus position and kind of tease out the Bernoulli equation, things like that. And it really like flips the approach from deductive to inductive. And it's really, really exciting. And it's an example, in my opinion, of how we really need to place more emphasis on empowering our students to think physically and grasp those first principles, especially in this sort of hyper digital age.
Yes, yeah, it's not, it's fantastic to hear that you're saying that as the world goes more digital, you're emphasizing even more the physical understanding of reality, because we can have, we can have people design a virtual airplane or medical implant, but nobody can fly in a virtual airplane
Right.
or fix their hip with a virtual implant.
At the end of the day, we live in the physical world, and computing and AI, and it's going to bring us to new heights. But uh, that's right on. And honestly, that's why I'm so excited about engineering and technology, and particularly mechanical engineering, because look at all of the challenges and opportunities the world faces, and how many of those have solutions that are rooted in physical technology, right? How do we compute more? We build hardware to do the computing, and we have to power it, and we have to cool it, and we have to stack it. How do we solve climate change? We need to find new ways to harvest and convert and store and recycle energy. Physical systems. I could go down the line.
No,
Uh,
it makes sense, because I know as a someone trained in mechanical engineering who's sells to mechanical engineering, although all we build is software here. But I believe that it's mechanical engineering that drives most of the digital world can't move forward without improvements in materials and products. And it's exciting to know that you're part of that, as you said. So three things I really want to thank you for and highlight as follow-up. First of all, thanks for teaching the next generation of mechanical engineers. Obviously, they're in great hands with someone who isn't just, you're not just saying this is the curriculum priorities of blending the digital and the physical, you're living it with your work. And that, I think that's really cool. You know, you're really living it. So thanks for teaching. Thanks for professional ed. I think that's a highlight I want to mention again to the audience. There's a class at MIT that you can take without enrolling in MIT, just as an engineer in industry. You can come for, it's a short class, right? Like you.
yes, it's a 3 or 4 day course. And again, feel free to reach out. We have different formats. You might find the 3 or 4 day short programs class in the summer. We also do specific workshops with companies. And then we have the online course that takes about 10 weeks, a few hours a week, and you can take at your leisure. And all of it is very interactive, but for different parts of the spectrum.
And so our audience, I particularly highlight for them, it's, you can go, there's a website, professional.mit.edu. You can do a Google search, you can email Professor Hart, but great opportunity. And then VulcanForms itself as a place that some of our listeners who are thinking, wow, I want to have product innovation. I want to do metal production of real complex parts at scale. They can contact VulcanForms, right, to
Yeah.
explore their opportunities. I think that's a great, and emphasize to our audience that VulcanForms isn't just another brand of 3D printer. It's a whole at-scale solution for actually getting parts that you'll need in pretty big quantities potentially, right? For our listeners, I know.
Yep, tens of thousands, hundreds of thousands, millions. That's also the beauty of the ability to modulate scale over time with a digital production system.
Cool. So cool. So I can't thank you enough for taking the time today to join us on the podcast. The time flew by. You're a person of many hats, and you seem to be balancing well. It's been a delight to know you over the years, visiting you at VulcanForms, visiting your class at MIT, which I did years ago. I remember guest lecturing, and what a delight and what an inspiration. Thank you so much.
Thank you, Jon. Thank you for doing this, for spending your time having this great series, and also for all your incredible contributions throughout your career. You're a very significant innovator in of course, in CAD, and in enabling, generations of new products to be designed. So it's a joy to know you and to have this conversation.
Well, it's so kind of you to say that. It's an honor, really. And I think that's it for today. See you all next episode on Masters of Engineering.